Friction. What is friction? Friction is a force which opposes the relative motion when two objects are in contact. See, friction is a force. Friction is a force. Friction is a force which opposes the relative motion when two objects are in contact. So friction is a force. First, very simple, you can tell about the force is nothing but a push or pull. Okay. Next one, which opposes the relative motion. What is relative motion? Any two objects are in motion with respect to each other. Is called relative motion. Already we discussed. Once again I am telling you, for just I will give example for this one. When you are going by the car, if you see outside nature with respect to your car, the trees and shops appears to be going backward. When car is going forward direction, the trees are going backward direction. And with respect to the tree or ground, your car is moving forward direction. So with respect to car and with respect to outside nature, two objects are car and outside nature, both are in motion. Any two objects are in motion with respect to each other is called relative motion. Okay. Next one, contact. What is contact force? See here, now this is my hand. I touch the one chalks. Now these two objects are, my hand and chalks is in contact. These two are in contact. When two objects are in contact, a force exists. That force we can call it is the contact force. For your understanding, I will give one diagram. See here, this is one horizontal ground. I placed one textbook or one duster, whatever it may be, just I placed on that one. Now this ground and object both are in contact. At that moment a force exists. That force we are calling it is contact force or reactional force. That force we can call it is the contact force or reactional force. For your understanding, see here, this is one hand and this one more. These two are in, I kept like this. Now these two bodies are in contact. At that moment, one force exists. That force name is contact force. That name we can call it is the reactional force also. Now this reactional force can be resolved into the two components. One is horizontal component is the frictional force. One more, it is the vertical component, that you can call it is the normal force. Reactional force can be resolved into the two components. One is horizontal component. This horizontal component name is the frictional force, and vertical component name we are calling it is the normal force. Vertical component name is normal and horizontal name is nothing but a friction. And what is frictional force? Okay, I am writing it is, what is friction? Frictional force. What is frictional force? See here, this is friction definition, and I am giving this frictional force definition according to this diagram. These two definitions are different. Okay. Now according to this one, see here, a force exists. Just I am giving again, it is nothing but a force exists. When two objects are in contact which is parallel to plane of contact, is called frictional force. According to this one I am saying here, again I am telling you here, Just read. Contact force are given. What is the contact force definition? A force exists when two objects are in contact, that is called contact force. See here, and here frictional force means a force exists when two objects are in contact. Up to here the definition is same, but I given one additional which is parallel to plane of contact. See here, now this is ground and this is object. Now these two are in contact. At that moment one force exists. That force is parallel to the plane of contact. What is plane of contact means? Where the two objects are in contact. See here, just I am keeping my hands like this means here these two objects are in contact. Where the two objects are in contact, that we can call it is the contact force. Here these two objects are in contact. That is nothing but a contact force. Okay, now that is plane of contact. Now this force is parallel to this plane of contact. See here, the plane of contact is like this, this force is like this. Now these two are in parallel. So which is parallel to plane of contact, that we can call it is the frictional force. This is the frictional force. Okay, now I am going to give the definition for the normal force. Normal force means, again same definition, a force exists when two objects are in contact which is perpendicular to plane of contact, which is perpendicular to plane of contact. See here, now these two objects are in contact and at that moment a force exists. That force is perpendicular to plane of contact. See here, the plane of contact is like this, the force is existed like this. Now these two are in perpendicular. So this force we are calling it is normal force. That force we can call it is normal force. Okay, now coming to this diagram now. This diagram just I am drawing like this. One it is F, one it is normal force and this one it is the reactional force. Now this reactional force, for your understanding, just I drawn one line, it is along this direction. Now these two are in parallel. At that moment, this normal force I have written like this. The normal force I have written like this. At that moment, see here, it is nothing but a right angle triangle. From the Pythagoras theorem, I am writing equation R square is equal to n square plus f square. Now R is equal to under root of n square plus f square. R is equal to under root of n square plus f square. When frictional force is equal to 0, if frictional force is equal to 0, at that moment R is equal to normal force. Reactional force is equal to normal force. When frictional force is 0, at that moment normal force is equal to 0. Okay, coming to our definition here. Friction is a force which opposes the relative motion. Friction is a force which opposes the relative motion, I am saying. See here, this is one object. Now this object is rolling. After covering some distance, it came to rest position. How it came to rest position? Why it's not continue the motion? If you kick the football in a ground, it covers some distance. After covering some distance, the football coming into the rest position. Why it is coming into the rest position means there is some opposing force. Due to that opposing force, the football it is coming into the rest position. For your understanding, I give one example here also. When object is projectile upward, just a projectile when object is upward, while it is going upward direction, the velocity of the object is decreasing. When it is reached maximum height, velocity comes to 0. When velocity is 0, it starts to fall down. See here. So while it is going upward direction, why velocity is decreasing? Why velocity is decreasing means because of the air resistance force. Because of the air resistance force, it is nothing but a friction, isn't it? Okay, I am telling you here, because there is a opposing force, we are calling it is the frictional force. So relative motion, it is opposing the relative motion. It opposes the relative motion. In any situation, can it support the motion? Can it support the motion? Yes. When you are walking on a ground, when you are walking on the ground, can you experience any opposing force? Can you experience any opposing force, children? We are not experience any opposing force while you are walking on the ground. While you are walking on the ground, you are not experience the opposing force. At that moment, frictional force is supporting the motion of the man. Frictional force is supporting the motion of the person. How it is here, the diagram? For example, this is the feet of a person. This is feet of a person. Now the feet is contact with the ground. The feet is contact with the ground. So this a contact force will be exist. That is nothing but a contact force will be exist. Now this contact force, reactional force, can be resolved into the two components. One is frictional force, one more it is normal force. See here, while a person is walking, frictional force is supporting the motion of a person. Frictional force is supporting the motion of a person, and normal force balancing the human body, isn't it? So frictional force sometimes it is oppose the motion of the body, and sometimes it supports the motion of the body also. It is not always. See here, which oppose the relative motion, I said, I given which oppose the relative motion, but I did not mention which oppose, always oppose. I didn't mention, because in some situation frictional force support the motion, in some situation frictional force oppose the motion. Okay, where you can observe this frictional force? I told you it is opposing. How you can say it is opposing means, for your understanding, I given an example here. While it is rolling, after covering some distance, from here to here it came, and after covering some distance it came to rest position. Why means, see my fingers, it is fingerprints is nothing but a up and downs. Fingerprints is nothing but a up and downs, isn't it? So it is nothing but a, we can call it is irregularities. This up and downs we can call it is irregularities. We can call it is irregularities. And at that moment the chalks also, by using of the mic, the chalks appears to be very smooth, but when you observe this one, by using of microscope, you can observe the irregularities. You can observe the irregularities like up and downs. When I hold these chalks, at that moment these irregularities may or may not be, interlocked. At that time only I can safely hold this chalk. When you are holding one, while you are eating the food, you can hold the spoon. How you can hold the spoon means, because of the frictional force. This irregularities cause the friction. On the ground, when you kick the football, see here, so many irregularities are there. When ball is moving forward direction, these irregularities oppose the motion. Motion of the ball. The irregularities motion of the ball. At that time only, after covering some distance, the football coming into the rest position. Isn't it? Whenever it is appears to be, for example, if you take any smooth surface, isn't it? Smooth surface, you feel it is smooth, but it is not a perfectly smooth surface. But if you want to find out whether it is smooth surface or rough surface means, you should observe that surface by using of the microscope. When you observe the microscope, if you found any irregularities, that is the rough surface. If there is no irregularities, that is the smooth surface. I will give one example. Can you walk on a smooth surface? We can unable to walk on a smooth surface. If you try to walk also, you will fall, isn't? Because on the smooth surface you can go. We are unable to walk. On a smooth surface we are unable to walk, isn't it? On the rough surface only we can safely walk. On the rough surface only we can safely walk. For example, in your shoes, if you observe your shoes, just see the bottom. You can observe spikes and grooves. You can observe the spikes and grooves like this. You can observe the spikes and grooves. These spikes and grooves is nothing but irregularities. These irregularities cause the friction. That is the rough surface. That is nothing but a rough surface, isn't it? Okay. So frictional force is nothing but oppose the motion and support the motion. Frictional force oppose the motion and support the motion. Okay, this is about, for example, which oppose the relative motion. I said one object is at rest position. When object is at rest position, isn't at that moment, is there any frictional force? When object is at rest position, frictional force is equal to 0. When object is at rest position, frictional force is equal to 0. When object is at rest position. Okay. Then after, we'll take here, when two objects are in contact, a force exists which is perpendicular to the plane of contact, that we can call it is normal force we are writing. And weight of the object is acting downward direction. Weight of the object is acting downward direction. See, is it moving up and down? Is it moving up and down? It is not moving up and down. At that moment, you can write upward forces is equal to downward force. This object is not moving up and down. So at that moment, normal force is equal to upward force is equal to downward force. Upward force is equal to downward force. And frictional force is directly proportional to normal force. Frictional force is directly proportional to normal force. When you remove the proportionality, one constant takes place, that we can call it is coefficient of friction. Here mu we can call it is coefficient of friction. Mu is we can call it is coefficient of friction. Mu we can call it is coefficient of friction. And this coefficient of friction, how we can define? Mu is equal to F divided by L. It is defined as the ratio of frictional force to normal force. It is coefficient of friction is defined as the ratio of frictional force to normal force. Okay. What are the units? See here, this is frictional force. Frictional force is nothing but a force. Force unit is Newton. Okay. Normal force. What is normal force? It is one kind of force. So it is also Newton unit. So Newton get cancelled. So at that moment, coefficient of friction does not have the units. No units. And no units means no dimensional formula. Okay. Advantages of the frictional force. Advantages. What are the advantages? Just already we discussed. Advantage of the frictional force means you can safely walk on the floor. I can safely hold the chalks, and we can hold the spoon for having the breakfast or lunch, dinner, whatever it may be, isn't it? Okay. When you are riding the bike on a road, there is a frictional force is acting between the tire and road. So that is nothing but one advantages. Okay. What are the disadvantages? The disadvantage of the frictional force is nothing but your shoes will be wear and tear. See here, can you wear your shoes long time? 10 years, 20 years, 40 years, we cannot wear. After 1 year, it will be wear and tear. So it is nothing but a disadvantage of the friction. It is nothing but a disadvantage. And when machinery parts, when in a companies, if it what about the machinery is continuously running, due to the frictional force, it produces the heat. Due to the frictional force only, it is produce the heat. So it causes to damage the machine. Isn't it? And also when it is producing the heat, also there is a loss of power. So that is nothing but a disadvantage of the frictional force. And how you can reduce this frictional force? We have it is the 4 methods. One, it is polishing. When you polish any two objects, we can reduce the frictional force. Means the irregularities will be vanish. when the irregularities will be vanish, isn't it? Okay, sandpaper, if you take the sandpaper and rub, isn't it? At that moment, the frictional force can be reduced. One more, it is the lubricants. For example, your floor it is nothing but a rough surface. Your floor it is nothing but a rough surface. If you want to make it is the smooth surface, just you can use the oil, drop the oil. At that moment, the irregularities will be filled with nothing but a oil, so that will be smooth. For your understanding, I am writing here. See here, on your floor you can observe the irregularities like this. If you drop the oil, the irregularities will be filled with oil. So this is nothing but will become as a smooth surface. That will become as a smooth surface. You can use the grease. Grease is nothing but one of the lubricant. When you are taking the water from the well, isn't it? Axle and wheel have between them you can use the grease. So by using of the grease, when you apply the grease, you can easily take out the water from the well. That is nothing but one of the advantages. That is how you can reduce the friction, means by using of the lubricants. Okay, next one, it is ball bearings. In cycle you can observe the ball bearings, isn't it? So that is the one of the method to reduce the frictional force. Next one, it is the streamlines. In automobiles we are using this streamline, means aeroplane you cannot take. Aeroplane, what is the shape of the aeroplane? The shape of the aeroplane is front like this. That is nothing but a front is like a V model. The front it is like a V shape. The speed of the aeroplane it is on the runway it is very high. The speed of aeroplane it is on a runway it is very high. When it is moving very fast, the airflow it is very high. The airflow it is opposite the motion of the aeroplane. The airflow it is opposite the motion of the aeroplane. For your understanding, just I will tell you, one heavy wind it is coming like this. Can I walk safely like this? I cannot walk. For example, if I want to go, I have to minimize my surface like this. If I minimize like this, and I can walk easily. Means when I am moving, when I stretch my body like this, means when airflow it is coming like this, means I am splitting the airflow. See here, if you take airflow it is coming like this. At the aeroplane it is moving along this direction. At that moment, this automobile splitting the airflow. So some of the airflow will be move along this direction, some quantity will be moved along this direction. We are splitting the airflow. At that moment, it will move very fastly without opposing force, isn't it? So that is nothing but a streamline. That is the streamline. These are the methods to reduce the frictional force and advantages of the frictional force. What is friction? What is relative motion? What is normal force? And where it is support the motion, where it is oppose the motion, and what is the frictional force formula and coefficient of frictional force formula. Types of frictional force. How many types of frictional force? We have it is 3 types. One, it is static frictional force. Static frictional force. Second one, it is kinetic frictional force. Kinetic frictional force. Third one, it is rolling frictional force. Rolling frictional force. It is types of frictional force. What is static frictional force? In Greek language, static means rest. You have to remember, in Greek language, static means rest position. Static means rest position. Static is rest. Static is rest. Now the object is at rest position. You have to remember, the object in static frictional force, the object is at rest position. Okay, I am giving one, just I am taking one object here, one object. Now force is try to move an object. One force is try to move an object. Just we are applying the force. When we start push that object, when we start the push the object, at that moment then there may be develop the opposing force. When we start pushing, there may be develop the opposing force. That force we can call it is the static frictional force, isn't it? For your understanding, I am saying this is one wall. The board is attached to the wall. Just I am discussing about the wall. Now I want to move this wall. I am applying the force. Just I am applying the force. When I start to move that object, at that moment, one opposing force will be developed. One opposing force will be developed. That opposing force we are calling it is the static frictional force. That opposing force we are calling it is the static frictional force. Okay. In the static frictional force, it is nothing but an object is always at rest position. Object is always at rest position. Now static frictional force is, static frictional force symbol we are writing as a F, as suffix is S, directly proportional to normal force, directly proportional to normal force. When you remove the proportionality, one constant takes place, that is mu s. Well, that is nothing but a mu s. Here mu s is called coefficient of static frictional force. Mu s is called coefficient of static frictional force. Coefficient of static frictional force, and mu s is equal to, you can write mu s divided by n. How we can define this one means, coefficient of static frictional force defined as, it is defined as ratio of static frictional force to normal force. Ratio of static frictional force to normal force is called, that is called coefficient of frictional force, is defined as ratio of static frictional force to static frictional force to normal force. Normal force is called coefficient of static frictional force. And coefficient of static frictional force also does not have the units and no dimensional formula. Okay. Next one, limiting frictional force. Limiting frictional force. Limiting frictional force. What is limiting frictional force? What is limiting frictional force? Here, I want this one I didn't write in this theorem. See here, types of frictional force is nothing but a static frictional force, kinetic frictional force, rolling frictional force only I have written. But where is the limiting frictional? It is nothing but a limiting frictional force means, for your understanding I am saying you here, one object, for your understanding, I am trying to pull this wall. At that moment, then there may be developed the opposing force. That opposing force what we are calling? Static frictional force. That opposing force we are calling it is the static frictional force. Okay. Now, according to that one only, just we have to give it is nothing but a opposing force. See here, one person is standing and applying the force on the wall. Applying the force. This is not a wall, one object. He is moving along this direction. He is applying the force along this direction. When he try to move that object, at that moment, opposing force, frictional force, opposing frictional force. This is capital F is applied force. Small f is nothing but a frictional force. Frictional force always oppose the motion. Okay. Now, when he try to move, frictional force is developed. Now the object is at rest position. See here, the frictional force have some capacity. Frictional force have some capacity. Here, the frictional force having only 10 newtons. Frictional force having only 10 newtons capacity only. But the person having it is the 15 newtons. He can apply the force. He can apply the force on this block. It is 15 newtons force. First, what he done? He applied 2 newtons force. Just he applied the 2 newtons force along this direction. At that moment, friction will also apply only 2 newtons. Frictional opposing force also apply only 2 newtons, but its capacity 10 newtons. It never applied like that 10 newtons. Just it is 2 newtons. It is applied like this means opposing force also applied 2 newtons. Now these two get cancelled. The resultant is 0. Now the block is at rest position. Now the block is rest. Okay. Now the person increased his capacity. He's increased the force. he applied the 7 newtons force. He applied the 7 newtons. At that moment, this frictional force also applied 7 newtons. The frictional force also applied 7 newtons. See here, both are equal and opposite, get cancelled. The block is at rest position. The block is at rest position. Now, the person applied 10 newtons force. The person applied 10 newtons along this direction. Now, frictional force having how much capacity? 10 newtons. It is also applied 10 newtons force. It is also applied 10 newtons force, isn't it? Now, these 10 newtons get cancelled. The object is at rest position. See here. If we increase more than 10, even 1.1 also, the object will move along this direction. The object will move along this direction. So at this position, this is maximum force only. This is maximum static frictional force. This maximum static frictional force, we are calling it is the limiting frictional force. Maximum static frictional force, we are calling it is the limiting frictional force. This is, then after, if you apply the 11 newtons force, the block is coming into the rest, but it can apply only 10 newtons only. So this maximum opposing force is there. That maximum opposing force, the maximum static frictional force, we can call it is the limiting frictional force. Maximum static frictional force. Maximum static frictional force. Maximum static frictional force is called limiting frictional force. Okay. This formula how we can write means FL is equal to mu S into L. See here, limiting frictional force is equal to coefficient of static frictional force into N. Why I have written S? Why you should not write L means the object is at rest position only. No? That's why we have to write this is mu S only. So limiting frictional force is equal to mu S into N. Limiting frictional force is equal to mu S into N. What is the limiting frictional force? Maximum static frictional force, we can call it is the limiting frictional force. Maximum static frictional force. Okay, next one. Second one, kinetic frictional force. Kinetic frictional force. What is kinetic frictional force means? When force is applied on object. Now, in the kinetic, actually, kinema is the Greek word. Kinema is the Greek word. In the Greek language, kinema means motion. Kinema means motion. In Greek language, kinema means motion. Now, the object is already in the motion. When object is, now here, when I am discussing about the kinetic frictional force, the object is already in the motion. Object is already in the motion. When object is in the already motion, there is a opposing force. There is a opposing force. There is a opposing force on a body. That opposing force we can call it is kinetic frictional force. Here, now the object is rolling. Now the object is rolling. At that moment, some opposing force is acting on this body. Some opposing force is acting on the body. That opposing force we are calling it is kinetic frictional force. Kinetic frictional force. Okay. Kinetic frictional force is directly proportional to N. Kinetic frictional force directly proportional to N. We can write this one, it is when you remove the proportionality, we can write mu k into N. Here what is mu k? Mu k we can call it is coefficient of kinetic frictional force. Okay. Now mu k is equal to, we can write Fk divided by N. How we can define this one? It is defined as the ratio of kinetic frictional force to normal force. It is defined as the ratio of kinetic frictional force to normal force. That is nothing but a coefficient of frictional force. Okay. Now, I told you, now the object is already in the motion. See here, applied force is along this direction. Frictional force is along this direction. Kinetic frictional force. How we can write the acceleration of the block means? See here. Applied force is along this direction, opposing force is along this direction. At that moment, free body diagram. So resultant force is equal to, now object is accelerating along this direction. So capital F, applied force minus opposing force. Applied force is like this, opposing force is like this. So both are opposite direction. Applied force minus kinetic frictional force is equal to, according to the Newton's second law, F is equal to ma, resultant force is equal to ma, F minus Fk. Then A is equal to, you can write F minus Fk divided by M. Applied force, acceleration of the block. Acceleration of the block, you can write it is nothing but a F minus mu k divided by M. Okay. Rolling frictional force. Next one, it is rolling frictional force. What is rolling frictional force means? When object is rolling on the other surface, when object is rolling, see the chalk is rolling on the other surface, my hand, the chalk is rolling on the other surface. At that moment, there is a opposing force on the object. The opposing force will be act. How the opposing force will be act? See here, take one box, rolling object. Circular object. If you take the one circular object, just if it is moving on a rough surface, it will be moving on a rough surface, it will becomes to the deforming position. It will be actually, see here, it is a circular object. While it is rolling, it will be coming into the deforming position or not. This is the actual position. But while it is rolling, the shape of the object will be changes. That is nothing but a opposing force is acting on the body. When object is moving, rolling on the other surface, isn't it? There is a opposing force is acting on the object. That opposing force we are calling it is the rolling frictional force. That opposing force we are calling it is the rolling frictional force. That rolling frictional force directly proportional to normal force. When you remove the proportionality, one constant will becomes, that you can call it is mu r is nothing but a coefficient of rolling frictional force. Coefficient of rolling frictional force, and mu r is equal to, you can write mu r is equal to Fr divided by N. Mu r is equal. How we can define this one means, it is defined as the ratio of rolling frictional force to normal force. It is defined as the ratio of rolling frictional force to normal force. And according to this one, you can write here, coefficient of static frictional force is greater than coefficient of kinetic frictional force is greater than coefficient of frictional force of rolling frictional force. Like this also you can write Fs greater than Fk greater than Fr. How can I give this one? Statement means, one bus is at rest position, there is a starting trouble. Now if you want to bring it to the motion, you have to apply the more applied force. For example, bus is in the motion. When it is bus is in the motion, if you can you apply the more force to move the object? No, the less force only. The force is decreases. See here, when object is at rest position, to move into the object, you have to apply the more force. When you are applying the more force means, more opposing force is there. So that is nothing but a starting trouble. That is nothing but a static frictional force is nothing but a more. Then after, when object is in the motion, you can apply the less force. So that's why only kinetic frictional force. But when object is rolling, that is less than this one. So coefficient of static frictional force is greater than the kinetic frictional force, and it is coefficient of kinetic frictional force is greater than the rolling frictional force. And this one you can write here, static frictional force is greater than the kinetic frictional force is greater than the pushing, pulling of land roller. Where you can observe the land roller, students, boys very much interested in cricket. In cricket ground, you can observe the land roller, isn't it? To smooth that surface, pitch, they use the land roller. Now, what about the pushing and pulling of the land roller? Now we are discussing. See here, I am taking one land roller as a circular shape. The land roller I am taking as a circular shape, isn't it? Pushing means we have to push like this. Okay? We are applying the force along this direction. At that moment, see here, it is making an angle with horizontal. This is applied force. We are pushing like this, isn't it? At that moment, applied force is with a horizontal is making an angle theta. Force is making an angle with horizontal is theta. At that moment, force can be resolved into the two components. Force can be resolved into the two components. One is horizontal component F cos theta. One more, it is vertical component is F sin theta. Vertical component is F sin theta, isn't it? See here, this land roller, it is contact with the ground. Land roller, it is contact with the ground. At that moment, a force can be exist. A force can be exist on the land roller, which is perpendicular to the plane of contact. This is plane of contact. Now, that is, we are calling it is normal force. Okay. Normal force is existed upward direction. Weight of the land roller, which direction it will be act? Weight of the land roller will be act downward direction. Okay. Weight of the object is acting downward direction. See here, it is not accelerating up and down. It is not accelerating up and down. At that moment, you can write upward forces is equal to downward forces. Upward force is the normal force. Downward forces are mg and f sin theta. Okay. mg plus f sin theta. mg plus f sin theta. Now, this land roller, it is moving or rolling. It is nothing but a rolling. Land roller can be roll, isn't it? So, it is nothing but there is a, when it is rolling on forward direction, there is a opposing force. That opposing force is nothing but a rolling frictional force. Opposing force is the rolling frictional force. This rolling frictional force is directly, already I given formula, but I am saying giving. Rolling frictional force is directly proportional to normal force. When you remove the proportionality, one constant takes place, that is mu r. Here, what is the mu r? Mu r is nothing but a coefficient of rolling frictional force. Mu r is nothing but a coefficient of rolling frictional force. And this is equation 1. Substitute equation 1 in equation 2. Substitute equation 1 in equation 2. Fr is equal to mu r. N is equal to mg plus f sin theta. mg plus f sin theta. Okay. This is one equation. For it is opposing. When you are pushing the land roller, opposing force, opposing rolling frictional force is nothing but a. When you are pushing like this, opposing force is how much it is acting? This one. Okay. Next one, pulling. Pulling means this is pushing. Pulling means you have to take the handle and move like this. That is the pulling. Okay. Now I am taking about the pulling. Now the land roller is like this, isn't it? When I am pulling like this here, we are pulling like this. We are pulling like this. So applied force is along this direction. It is making an angle with horizontal, it is theta. Okay. Now this F can be resolved into the two components. One is horizontal component is F cos theta. Horizontal component is F cos theta. Vertical component is F sin theta. Vertical component is F sin theta. And we have to discuss about two more forces. One is normal force, one is weight of the object. Normal force acting on the body due to the ground, it is upward. Normal force is upward. Weight of the object is always downward direction. Weight of the land roller, it is downward. Now the body is not going upward direction. It is not going up and down. So you can write upward forces is equal to downward forces. F sin theta plus N is equal to mg. Okay, N is equal to mg minus F sin theta. N is equal to mg minus F sin theta. Now you know formula. Fr is equal to mu r into N. Now N value you have to substitute here. Opposing frictional force is equal to mu r into mg minus F sin theta. This is when you are pulling the land roller, opposing frictional force is this one. So now I want to ask the question, which one is easy to push the land roller or to pull the land roller? Which one is easy? See here, you have to conclude here opposing force. This is pushing opposing force and this is pulling opposing force. Which one is more? Which one is more means here mg plus f sin theta. It is addition. So we can get values, some more value. Here mg minus f sin theta. Some value is subtracted from this one. At that moment, this is less. Opposing force is less here and this is opposing force is more. For your understanding, I am saying weight is 10. Mg is equal to 10 kg and f sin theta is nothing but 2 newtons. How much you can get? That is opposing force is the 12. Here mg is the 10. F sin theta what I taken 2 minus 2, that is equal to 8. See here 12. Opposing force is the 12 newtons. Opposing force is the 12 newtons and it is here opposing force is the 8 newtons. So this is nothing but a pulling is easier than the pushing. Pulling is easier than the pushing. Pulling is easier than pushing.